All right, this is the seventh grade probability and likelihood topic. Let's get right into it. Number one, the probability of randomly selecting a white flower from a garden that has green, pink, yellow, and white flowers is 3%. So the probability of selecting a white flower out of all these is just 3%. Which of the following describes the likelihood of selecting a white flower? Is it likely, neither unlikely nor likely, or is it unlikely? Well, 50% would be neither unlikely nor likely. If the probability of something happening is 50%, that means there's a 50% chance that it does happen and a 50% chance that it doesn't happen because all the percentages need to add up to 100%. So there's a 50% chance it does happen. There has to be a 50% chance that it does not happen. In this one, our percentage that picking a white flower happens is much less than 50%. It's a very small percentage, it's just 3%, which means there's a 97% chance that it does not happen. So, what is the likelihood of selecting a white flower? The likelihood of selecting a white flower is very low. It is unlikely that you will get a white flower. You only have a 3% chance of getting a white flower. You have a 97% chance of getting something else. So, it is unlikely that you get a white flower. If the percent chance of getting a white flower is less than 50%, if it's less than 50% chance of happening, it's unlikely. If it's more than 50% chance of happening, it's likely. And if it's exactly 50% chance, it's neither unlikely nor likely. Number two, Noel is playing a game where he draws one playing card each out of two stacks of five cards. So he's got two stacks of five cards, and he's going to draw one card from each of those stack of five. So he's got 10 total. The table below shows all possible sums for the two numbers on the cards. So he's got a blue stack of five cards where there's a 3, a 6, a 7, a 9, and an 11. And he's got a stack of five red cards that are 1, 4, 6, 8, and 12. Is Noel more likely to draw two cards with a sum that is a multiple of 3 or two cards with a sum that is greater than 13? So all of these answers in the middle here, all these black numbers, are all the sums. If I pull a 3 into 1, or if Noel pulls a 3 into 1, the sum is 4. So that's why it says 4 on the intersection of the 3 and the 1. If he pulls a 6 into 1, the sum is 7. Well, if he pulls a 6 into 4, the sum is 10. So all of these black numbers are the sums. So we just have to figure out, to answer this question, how many are a multiple of 3 and how many are greater than 13. So let's start with the first. How many of these numbers are a multiple of 3? Because we care about whether it's more likely that he gets a multiple of 3 or a number greater than 13. So we'll start with multiples of 3. So we'll count them. 4, no. 7, no. 8, no. 10, no. 12, yes. That's 1. No, 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 no. 15, that's 2. 9, yes, that's 3. 12, yes, that's 4. 13, no. 15, yes, that's 5. No, no, no. 15 again, that's 6. No, no. 15 again, that's 7. 18, yes, that's 8. 19, no. 21, yes, that's 9. And 23, no. So again, just ran through and found out how many multiples of 3 there were in these 25 combinations possible. So again, 1, 2, 3, 4, 5, 6, 7, 8, and I believe 9 was another one. So again, one more time. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 9 out of 25 combinations are a multiple of 3. So 9 out of 25. Now, if I'm looking at these, how many of these things say 9 out of 25? Literally only C says 9 out of 25. So it probably is going to be the answer. Now let's go ahead and count how many are greater than 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now this says 12, so let's count it one more time to make sure I didn't mess up. I may have accidentally counted to 13, but those don't count. It has to be greater than 13. So here we go. Count one more time. Any greater than 12 here or greater than 13? No, 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 no. No, 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 no. Yes, 15. That's 1, 2, 3. No, 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 no. 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 12 out of 25 are greater than 13, but only 9 out of 25 are multiples of 3. So C is the right answer. Noel is more likely to draw 2 cards with a sum that is greater than 13 because 12 25ths, or 12 out of 25, is greater than 9 25ths, 9 out of 25. At Marissa's birthday party, she writes the name of each guest on a separate strip of paper as shown below. So we got a bunch of names there. She draws one name at random to win a prize. Place the following events in the appropriate category of the table below. So which ones are unlikely, which ones are likely, and which ones are neither likely nor unlikely. So if we randomly pick one of these names, how many names are there? We've got, looks like 4 rows of 4, so that's 16 names. So everything here is going to be out of 16. That's what everybody's probably, there are 16 total options. So we're going to do probabilities out of 16. Let's start with drawing a name that starts with the letter J. How many of these names start with the letter J? I'm going to go ahead and put a dot. I'll put a blue dot on every name that starts with J. It'll be easier to count that way. So here we go. 1, 2, 3, 4. So I see 4. So there are 1, 2, 3, 4 names that start with J. So if I have 4 names that start with J, that is unlikely to be the thing that happens because 4 out of 16 is less than half. It's less than 50%. 4 out of 16 is less than half, so something that has a probability of 4 out of 16 is unlikely to happen. Next one, drawing a name with less than 6 letters. So let's go pick all the names with less than 6 letters, and this time I'll put a green dot on them. Keep track of them that way. Less than 6 letters. Okay, John, that's less than 6. Carla, that's 5. That's less than 6. Morgan's exactly 6. We're not going to count that. It says less than 6. Has to be 5 or fewer. Peter counts, not Jennifer. Tyler, that's only 5. Mike, that's only 4. Cheryl is exactly 6. I don't count that. Francis is 7. Too many. Juan, Sarah, Fran. Stephanie's too many. Thomas is exactly 6. Too many. Melissa's too many. So how many green dots do we have? 1, 2, 3, 4, 5, 6, 7, 8. Exactly 8 out of 16. 8 out of 16 is 1/2. So it's neither likely nor unlikely. It's just as likely to happen as it is to not happen. 8 out of 16 chance it does happen. 8 out of 16 chance it does not. Whereas the name starting with J, only 4 out of 16 chance that it happens, which means there's a 12 out of 16 chance that it doesn't happen. So that's why this one's unlikely. Let's do the next one. Drawing a name with more than 5 letters. So more than 5 letters should be all the rest of them, because less than 6 letters was 5 or fewer. So all the other letters, or all the other names, I should say, should have more than 5. 6 or more is more than 5. So if 8 out of 16 had 5 or fewer, that's less than 6, then 8 out of 16 is going to have 5, more than 5. So again, we could go through and count those again. I can use a different color if I feel like it. How about red? Morgan, that's 6, so that's more than 5. Jennifer's more than 5. Cheryl's more than 5. Francis more than 5. Melissa more than 5. Thomas more than 5. Jeremiah more than 5. Stephanie more than 5. And how many? Did we skip anybody? 1, 2, 3, 4, 5, 6, 7, 8. So now everybody's got a red dot or a green dot. Remember, the green dots are less than 6 letters, so that's 5 or fewer. And the red dots are more than 5, so that's 6 or more. Last but not least, let's put a dot on everybody that is drawing a name that does not end in a vowel. So everybody that does not end in a vowel, put a pink dot. John ends in N, that's a consonant, not a vowel. Carla ends in A, that's a vowel. Morgan, N, not a vowel. R, not a vowel. R, not a vowel. R, not a vowel. E, that is a vowel. L, not a vowel. S, not a vowel. H, not a vowel. N, not a vowel. H, not a vowel. N, not a vowel. E, that is a vowel. S, not a vowel. And H, not a vowel. Okay, how many pink dots do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that means there's 13 out of 16 that do not end in a vowel. So drawing a name that does not end in a vowel is likely to occur. So there's our results. Number 4, which of the following is a true statement? A probability near 1 indicates a likely event. What does it mean near 1? 1 or 1.0 represents 100%, which is a nearly certain thing to happen. So a probability near 1 is almost certain, so that would be likely. A appears to be true. Let's read through the rest of these and make sure we understand why they are not true. Again, a probability near 1 would be 100%. 1.0 is 100%. So if it's near 1, it's almost certain, so it's a likely event. A probability near 1/2 indicates an unlikely event. Well, no, because 1/2 is neither likely nor unlikely. It's exactly as likely to happen as it is not to happen. So just because it's near 1/2 doesn't mean that it's unlikely. It could be near 1/2, but slightly over the 50%, slightly over 1/2, and that could be a likely event. So B is not true. C, a probability near 1 indicates an unlikely event. That's not true because something that's near 100% is almost certain, so it's much more likely than unlikely. And lastly, a probability near 0 indicates a likely event, and that's not true. A probability of 0 would be 0% chance of happening. Something that has a 0% chance of happening is impossible. So something that's near 0 is very unlikely to happen. So A is our answer. Number 5, the probability of randomly selecting a brown dog from 36 dogs in a local animal shelter is 50%. Which of the following describes the likelihood of selecting a brown dog? Well, selecting a brown dog is 50%. So it's a 50% chance you don't get a brown dog. If the chance that you get the brown dog and the chance that you don't get the brown dog is the same, they're both 50%, then it's neither likely nor unlikely. And that's A here. It's not unlikely, but it's also not likely. It's neither. It's 50% chance that it happens, which means it's a 50% chance that it does not happen. Number 6, the probability of randomly selecting a name starting with the letter T from a bowl of 24 names is 12/24. Which of the following describes the likelihood of selecting a name with the letter T? Well, 12 out of 24, if you simplify that fraction, you get 1/2. 12 and 24 both divide by 12. So simplifying 12/24 would get you 1/2, and 1/2 is the same as 50%. If you express a probability as a fraction and you get 1/2, that's the same as expressing that probability as a percentage and getting 50%. The probability of 1/2 is a probability of 50%. So just like the previous problem, if it has a 1/2 probability, that means half the time it will happen, half the time it doesn't. So neither unlikely nor likely. It's the same. Number 7, Travis performed an experiment in which he spun a spinner multiple times. So a spinner, like you might play a game with, a little arrow on a circular board, it spins around and randomly lands on a section of the spinner. The sections of the spinner are red, orange, yellow, green, and blue. The results of his experiment are shown below. So he did it a bunch of times. 9 times that he spun the spinner, he got red. 14 times he spun the spinner, he got orange. 7 times he spun the spinner, he got yellow. 18 times he spun the spinner, he got green. And 6 times he spun the spinner. 6 times he spun the spinner, he got blue. Based on the experiment above, which of the following statements is true? It is less likely for the next spin to land on red as opposed to yellow. So we're going to compare red to yellow. Is red less likely than yellow? Well, it landed on red 9 times, but it only landed on yellow 7 times. So, from the results that we have, it would seem that red is probably a bit more likely than yellow since it landed on red more times than yellow. So, A does not appear to be true. B, it is twice as likely for the next spin to land on green as opposed to red. Okay, how many times did it land on green? 18 times. How many times did it land on red? 9 times. In fact, it did land on green twice as often as red. So, from this information, we would assume that green is twice as likely as red because it landed on green twice as many times. So, B does seem to be true. Let's read the other two choices and make sure we understand why they're false. C says it is more likely for the next spin to land on orange as opposed to green. Orange is 14 times, but green was 18 times. So green was more likely. But this says it's more likely to be orange. So that's false. Green happened more times than orange did, so green is more likely. So C is false. And finally, D. It is equally likely for the next spin to land on yellow or blue. Well, yellow was 7 and 6, and blue was 6. Those are close, but yellow had one more time. So if this is all the information we had, we have our best guesses being that yellow is just slightly more likely than blue. Not that they're equal, although they are very close. B is a much better answer than D. D would be false because from this information, yellow is slightly more likely than blue. They are not equal. Number 8. Diners at several restaurants were surveyed to see what day of the week they prefer to go out to eat. The following table gives us some of the data collected by the restaurants. So we've got restaurant A, B, C, D, and E. We've got the number of customers who prefer Saturdays and the number of customers surveyed for each of those restaurants. If each restaurant selects one customer from the group of people surveyed, selecting a customer who prefers to go out to eat on Saturday is an unlikely event for, and we've got a drop down menu. So let's figure out which restaurants it's unlikely that the customer that they pick would prefer to eat on Saturdays. Let me bring back our little colors here. I'm going to put a pink dot on the ones that are unlikely. So A, 26 out of 30 did prefer Saturdays. We want to select the customers who prefer to go out to eat on Saturday as unlikely. Well, for 26 out of 30, that's more than half. So that is likely, not unlikely. So A does not fit this. 35 prefer Saturdays for restaurant B, but that's out of 72. 35 is less than half of 72. Half of 72 is 36. So 35 out of 72 would mean that fewer prefer to go eat out on Saturdays than do. So it would be unlikely that we would pick somebody out of these 72 people that prefers to eat on Saturdays because less than half of them prefer to eat on Saturdays. So B is one of the restaurants this is true for. 38 out of 143 is less than half also. So if we were to choose restaurant C, we would also be unlikely to pick somebody who prefers to eat on Saturdays. 15 out of 64 is less than half, so restaurant D also fits. Restaurant E, though, is 63 out of 74. That is more than half. So restaurants B, C, and D had less than half of the people they surveyed say that they prefer to eat on Saturdays. So it's as if each restaurant selects one customer from the group of people surveyed. So for restaurant B, that's one person of the 72. For restaurant C, that's one person of the 143. And for restaurant D, that's one person of the 64. Selecting a customer who prefers to go out to eat on Saturday is an unlikely event for restaurants B, C, and D. So let's go ahead and find those in the drop-down menu here. Now, I chose restaurants C and D because definitely restaurants C and D are less than half. Restaurant B is closer to 50%, but it's still less than half. I think there might be an error in this problem. We're going to find out if I get this right or wrong here. I assume that it's restaurants C and D, but also restaurant B, 35 out of 72 is less than half. So that is unlikely that you would select one of those 35 people out of a group of 72. So let's move forward and see if we run into an error there. If each restaurant selects one customer from the group of people surveyed, selecting a customer who prefers to go out to eat on Saturday is a likely event for restaurants A and E, because A has 26 out of 30, that's more than half. E is 63 out of 74, so we're going to say restaurants A and E. And then last but not least, if each restaurant selects one customer from the group of people surveyed, selecting a customer who prefers to go out to eat on a Saturday is neither a likely nor unlikely event. For restaurant B would probably be the answer they're looking for. This should say 36 out of 72. That being said, 35 out of 72 is really close to half. So maybe what they're trying to get at is that when you do a sample of these things, sometimes they're not always looking for an exact answer. But in that other problem that we did earlier, they were looking for a pretty exact answer. So Study Island can be kind of finicky sometimes. And in this case, we're going to choose the best answers available to us. So clearly, restaurants C and D had way less than half of the people prefer to go out to eat on Saturdays. So those are going to be unlikely. Clearly, restaurants A and E had way more than half of the people that do prefer to eat out on Saturdays, and restaurant B was very close to half. So this is our most likely set of answers, and we'll submit that, and I expect that those will be correct. There we go. Next one up. Number 9, a weather service has predicted that there is a 20% chance of rain tomorrow. Which statement is true about the likelihood of the event? Well, 20% is less than half. So, is it certain that it will rain? No, certain means it's a 100% chance going to happen. Nothing could stop it. 20%, that's definitely not certain. B, it is impossible that it will rain tomorrow? No, if it was impossible, the chance would be 0%. So that's certainly not true. C, it is likely that it will rain tomorrow. No, likely events have to be more than 50%, and 20% is certainly not more than 50%. D, it is unlikely that it will rain. That is what we're looking for. We have less than a 50% chance, so it's unlikely, but it is more than 0%, so we don't say it's impossible. We just say it's unlikely. And number 10, fill in the blank. The probability of a chance event is numbered between 0 and blank that expresses the likelihood of the event occurring. It cannot be more than 1. You cannot have a chance of something happening be more than 100%. 0 is 0%. 1 or 1.0 is 100%. So you're looking for 1 here. Not 100, because 1 as a number translates to 100%, which translates to 1 over 1 as a fraction. 1/2 would be 50%. 100 would be 10,000%. 1/10 would be 10%. So if you're just looking at a numeric value, then 1 is the highest probability that you could have. And that's it. Good luck. Don't forget that you've got a lesson back here. You've got some examples and things that you can go through. You got a few more pages of stuff. So please make sure that you are using the lessons to your advantage. Work hard and good luck.